Okay, good morning. So, welcome to the second question for today, which is on criterion B. So, the question reads like this. A second student decides to investigate how changing type of material like copper, aluminium, glass affects the rate of heat transfer to a rod of constant length. So, we have said the rod of constant length is not changing, cross-sectional area is not changing. Okay, and this will be used to compare the thermal conductivity of different materials. So, that's what we are going to look at. What we do is we will take a rod of given length and cross sectional area. So this length and area of cross section will be the same for all rods. Okay, for example, we will take up something like copper, aluminium, glass, bronze. We'll take up more copper, silver is cost. We'll take up say iron. I'm going to take 5 different rods over here, and then I'm going to heat it here. So before heating, what I do is I find out what is the initial temperature of this. I'm going to find out the initial temperature. That's it here. Now I will put a condition saying that if the temperature becomes the final temperature, let it increase by 10 degrees centigrade. It's Ti plus 10. And let us say if this is something like initial temperature, if I keep it at 30 degrees centigrade, the room temperature, after that I'm going to heat it. I'm going to heat it, and then I'm going to see that this becomes 40 degrees centigrade. And I'm going to compute the time for the heat to percolate or to transfer 30 to 40. What is the time? What is the time? That's what we're going to do. Okay. So if that is the case, now how do we proceed further? Now we have decided something. We have said that time difference is, sorry, temperature difference is 10 degree. Temperature difference is 10 degree, and then we are going to find out what is the time of it. And now design an investigation that the student could use to correct the data. In your answer, you should include the independent and dependent variables. First, let us answer this question because it's 14 marks. So one by one we have to go. So independent and dependent variables. What is your independent variable? The type of the rod or material of the rod, you can say. Type of the rod or material of the rod, okay, which could be of 5 different types. We are going to use it over here. And this is your independent variable. Dependent variable. What's your dependent variable here? Time taken to heat the rod by 10 degrees Celsius. This is your dependent variable. Okay. Now let us go further. 2 control variables with justification. What are the control variables? Already control variables are given. See, it's written over here. Where is it? Constant length and cross-sectional area. Okay, you are not going to change it. So, length of the rod. Don't just mention length of the rod. Then, cross-sectional area. See, whenever we talk about a variable should be a measurable one. Okay. For example, if I ask you to find out what is the cross-sectional area of this pen, you will not be able to measure it. Okay, you are not able to measure this one. You are able to calculate this. Now, how do you measure this? What is that you can measure? What you actually do is you find out the thickness of it, which will give you the diameter of the rod, and then you will find out what is the radius, and then based on this, you will do pi r square, right? Find out the cross-sectional area. So therefore, what is the measurable parameter here? The thickness of the rod, right? So you have to mention thickness of the rod. Thickness of the rod, the next one, and then maybe you can put one more variable also. What is that variable? This will be more appropriate. Which one? See, we said that the temperature difference between the two, that is the initial reading and the final reading, would be 10 degrees centigrade. Okay. So temperature difference between the ends of the rod is equal to 10 degrees centigrade. That's what we are going to look at. Okay. Now, a detailed method for the data collection. Now, how are we going to do the data collection? That was the question. Now, how do you do the data collection? The first one. Now, what is that we need? We are going to have a Bunsen burner. Now, if I keep a Bunsen burner and I keep a rod over here, and I initially measure this temperature, Okay, and then how do I measure the temperature? Now there is a risk here. The risk is that if you take a thermometer and keep it nearby to this one, what can happen? Because of the heat, it can burn up, or maybe it can break up, right? The bulb can break up over here. So I don't want to risk. What's the other method to do it? I will do it by a different method. Instead of using a burner, Bunsen burner, I will use a beaker. Okay. Fill it with water, and let us say, for example, I'll not fill it water. I fill it water like this, and then what I'll do is I'll start heating this one. See to it that I insert a thermometer here, and then I measure what is the temperature. Okay, and initially when I started with the temperature was going to be only 40. Now I make it to boil. When I make it to boil, this is a reach 100 degrees. And as a result of this, what can happen? So the thermometer will show 100 degrees. And then what I will do is, I will insert the rod. How do I insert the rod? If I take the rod and insert it like this, then what can happen? The entire part of this rod is getting heated. I should not do this one. So somewhere, I want to see to it that only this part of the rod is inserted, the rest of them is not inserted. So what should I do? My diagram is incorrect. My diagram should have been like this. This is the beaker, and let me say I put water on here, and then I put the thermometer here to measure what is the temperature of it, and then I put the rod here, with the help of a clamp and boss stand, the retard stand, whatever you call it. So I put it across here, holding this. So this is the length of the rod, and I am going to find out what is called temperature change by inserting one more thermometer here, by keeping the temperature sensor, and I am going to find out what the thermometer reads. I think this would work properly. Okay, now we have decided all this. So we are going to find out what is the initial temperature. Every time I need not find the initial temperature because I am already boiling this water over here. So the initial temperature will always be 100 degrees Celsius. Okay, and what I can find out is so initially what was the temperature of the rod before I dipped into it. Then after dipping into it, I will I'll start heating it and see to it that the water continuously starts boiling. That means I'm providing a continuous supply of heat energy, so that the water is always maintained at 100 degrees Celsius, and then it transfers energy to it, and wait until this end of the rod becomes okay. So initially it was, let us say, at 30 degrees centigrade, for example. This becomes 40 degrees centigrade. Okay, this would be 100 degrees centigrade, but this is initially before dipping the rod inside water. It was 30. After dipping it and waiting for some time, this will become 40, and I'm going to find out what is the time taken for this one to happen. Is it clear? Okay, first the methodology should be clear for us, and after that we can proceed. Now we will write down what we are going to do. The first one, what are you going to do? You are going to arranging the apparatus. So a beaker with half filled with water, is kept on a heat source, and the temperature is set to increase. Until 100 degrees boiling. The first thing that I put. Then the rod whose thermal properties as determined. Write the example. So as determined will be inserted that rod is heated uniform. Rod is heated uniform. Then what's the next step we are going to do? Next step is third one. The initial temperature of water is initial temperature of the rod before immersing water is noted Ti, and the time taken for increase of this temperature by 10 degrees Celsius, that is T final is equal to T initial plus 10, is measured using a stopwatch. That is something initial temperature of the rod before immersing is noted using a thermometer. What kind of thermometer you have to mention? Okay, this is. So now we have inserted the rod, we are finding out what is the time taken, we done all this. Next, what is the next step? Readings are happening. Readings are tabulated. The tabular column. Okay. Let's see whether we have presented everything. Detailed method for the collection of data. We have done all. 4 properties, 4 points we have mentioned, 4 parts. Fully. Okay. Let us move on to the next one. An explanation of how you will collect the sufficient data. How do you collect sufficient data? So what will you do? So, for 3 marks, Ti and Tf are noted for the rod. This is a repetition of what we have done earlier. And secondly, say for each rod, I think I have to write it. For each rod, Ti and Tf are noted for rod, and the steps mentioned from 1 to 4, the previous question are repeated for each rod. The first thing to write. Then 3 trials are taken for observing the time for each rod and the average calculated using the formula T average is equal to T1 plus T2 plus T3 divided by 2. Okay, this is what you have to mention very clearly. Finally, this is what you do. The readings are tabulated. Okay. Next, the statement of how data will be processed to compare the rate of expansion. Now, how do you process data? What you do now? Let us look back question over here. The question tells you they will use this to compare to the statement cross compare. When the command term says compare, how do you compare? That is it. Okay. So towards it, what you do is then put a graph. What kind of graph will I use? Whenever the x-axis, which is your independent variable, is a number, it's a continuous variable, then you can always use something like a graph, a straight line graph to compare this. But if it is something like the ordinal variable, that means the name is being present over here. Name is given over here. For example, what kind of variable you have? You have something like copper here, iron ore here, gas here, so on. In that case, you cannot use a straight line graph, but instead we will use a bar graph. And what will be on the y-axis? You will be having on the y-axis something like the time taken. T1, let's say 5 minutes, 7 minutes, 11 minutes, so on. So this is what we get. Okay. So now we have got the graphs. What is that we are going to plot the graph. And what does this graph tell you? Let's say I have this glass one, it's having a lengthier graph, a lengthier bar. So what does it tell you? It tells me this is a perfect insulator. Now I need 3 marks. I have 3 marks. So now I need to write it. Okay. The first one I can say the average values of time taken from the table are plotted along the y-axis against the type of rod plotted along the x-axis. First point. Secondly, bar graph is drawn using this data. That's the you need to interpret. What is the interpretation? Longer the bar, higher the time taken to heat. This implies that smaller bars are good conductors. That's okay. So if you write so much, get the full mark. Okay. So thank you for watching the video. And in the next video, we will see one more example from criterion. So totally 4 videos per week. First day was today. Criterion A you have already seen. Tomorrow it's criterion B, criterion C, and D also. Thank you. Do like, share,